Hey, what's up guys? Welcome to the second part of the Cayley Hamilton Theorem video. So in the previous video we already introduced Cayley Hamilton Theorem and we talked about the approach to find the inverse of a matrix using Cayley Hamilton Theorem. So in today's video, that is the second part of the Cayley Hamilton Theorem, we are going to talk about the second application of Cayley Hamilton Theorem, that is to find out the matrix of higher power in terms of lower power. Okay, so let us do a question in order to solve this problem, in order to solve this theory. Okay, so the question goes like this. You are given a matrix A, so I will just repeat the previous matrix that we did for the last video using Cayley Hamilton Theorem to find out the inverse. So it was 1, 3, 4, 2. And the question says that this A is given, so we need to express A to the power 5 in terms of linear polynomial in A. Linear polynomial in A. So we are going to use Cayley Hamilton Theorem to express A to the power 5 in terms of linear polynomial in A. Okay. So to start off with the solution, we have to find out the characteristic equation, and using the characteristic equation we have to figure out the equation of lambda, just like we did in the previous video. And from there we have to convert the lambda into A and then use the equation in order to find this. Okay, so just like the previous one, we are going to use A minus lambda I equals to 0, and we are going to put the values. So A was 1, 3, 4, 2 minus lambda into I will be lambda 0, 0, lambda, and that will be equals to 0. So finally we get determinant of 1 minus lambda, 3, 4, 2 minus lambda, which will be equals to 0. And by solving the particular determinant, we are getting lambda squared minus 3 lambda minus 10 equals to 0. So if you have not understood how we have solved this, I will just request you to watch the previous video on Cayley Hamilton Theorem where we found out the inverse of a matrix. So there I have explained how we had find out the determinant and everything. So this is just the quadratic equation in terms of lambda that we have received. Now we are going to do the Cayley Hamilton Theorem where we are going to replace lambda with A and find out the equation from there. So let us wipe out what we have already written. So the equation that we have received is lambda square minus 3 lambda minus 10 equals to 0. Now using Cayley Hamilton Theorem, so using Cayley Hamilton Theorem we can write A square minus 3A minus 10I equals to 0. A squared minus 3A minus 10I equals to 0. Okay. Now again we can say A square equals to 3A plus 10I. A square equals to 3A plus 10I. This is equation number 1. Now we have to find out A5 in terms of A, and now we have is A square in terms of A. So now we are going to increase the power and we are using this particular theorem for this. So now if I multiply a square with another a into a, so what does it become? It becomes a cube. And similarly, we will also multiply a with this particular thing, so it becomes 3a square plus 10a, because a into I is nothing but a. So 3a square plus 10a. Now we can also replace this a square with equation 1. So we can write 3 into a square was 3a plus 10i, 3a plus 10i plus 10a plus 10a. Now why did we do that? Because we have to represent a5 in terms of a. So first we will start with a square in terms of a, then we will go to a cube in terms of a, then we will go to a4 in terms of a, then we will go to a5 in terms of a. So a cube in terms of a square we have this particular value, and now in terms of a we are going to receive the value. So if we follow this particular system, it's 3 into 3, 9a, okay, plus 3 into 10, which is 30i, okay, plus 10a. So your final value of a cube in terms of a shall be, so 9a plus 10a, which is 19a, plus 30i, 19a plus 30i. Okay, so that is the value of a cube. Now let us go to the next value, which is to find the value of a4 in terms of a, and like this we are going to find the a5 also. So now we are going to find a cube into a, which is nothing but a4. So that shall be, so a cube was this one into a, so it will be 19a square plus 30a. I into a is a. So 19a square plus 30a. Again, here using equation 1, we know a square is nothing but 3a plus 10i. So it will be 3a plus 10i plus 30a. So 19 into 3 will be 57. A plus 190i plus 30a, and we have 57a and 30a, 87a plus 190i. So that is the value of a4. Okay, that is the value of a4. Now the last one, that is to find the value of a5. So we need to multiply a4 with a so that we receive a5, and on the process we are also going to multiply this thing with a, so that shall be 87a square plus 190i, sorry, it will be a now. Okay, a into I is a. So again the same process, 87 a square, in place of that we can write 3a plus 10i, 3a plus 10i plus 190a. So 87 into 3 gives something like in total it will come as 451a in total, like 87 into 3 plus this 190. Okay, I don't have the calculator right now, I'm just relying on the answer. You just also check if you are receiving the same answer. So it will be I think 87 into 3 will be something around what was that, I don't remember. Okay, anyways, we will stick on to 451a. Okay, if there is a mistake, you just correct me. 451a plus 810i. 870 870i. Okay, so it will not be 810, 870i. We can just check it here. 87 into 3 will be giving us 21, carrying 2. 261, and here is 190. So 1, 5 and 4. Yes, so it's correct. 451a plus 870i. So this is the total value of a to the power 5. So we have reduced the polynomial of a to the power 5 in terms of a. So that is how, using Cayley Hamilton theorem, we can solve this particular problem. So this is the second approach of Cayley Hamilton theorem. So that ends the topic of Cayley Hamilton theorem. In the next video, we are going to introduce some new chapters from engineering mathematics. And till then, please keep watching. Okay, bye-bye.